So the last thing I'm going to talk about is an ANOVA that I ran. And again, I already clicked through all the menus and everything, so we just have the output here to look at. I ran an ANOVA, a 2x2 ANOVA. The two factors were X1, which has two levels, as well as X2A, which has two levels. We're measuring their effect on the dependent variable Y. So before we even interpret this, though, we have to be careful because SPSS, as warned by Lewis and Marquise, SPSS uses over-parameterized ANOVA models, and so we have to be careful when we're interpreting our values here. Just want to say that before we actually go ahead and interpret it. So I ran the ANOVA, and we can look at our descriptive statistics if we want to. I'm not going to go into details on that. Really want to look at the real outcome of the test. And first we can look at the overall test, the omnibus test that just shows whether our model in general, if there's a difference somewhere, and we can go forward if we find some sort of significance there, which we definitely do. It's very significant, which is good because if not, we would stop there. So we know there's some difference somewhere, and we want to find out the nature of that difference. Again, we could also look at the R-squared, which shows a relationship, again, between ANOVA and regression and showing the overall ability of this model to predict differences in the dependent variable. But moving forward to look at the actual nature of the effects, we can first see if there was a significant main effect of X1. And we see that there is, in fact, a significant main effect. But before I go into too much detail about interpreting the significance of these effects, it is important to hark back to what we've learned all throughout the semester, that you have to be careful in your interpretation of null hypothesis significance testing. And we've learned about this and read a lot of papers on it, but there's been several papers recently that all talk to the same point again. The paper by Kirk, again, talked about the common mistake of just placing too much emphasis on this artificial p-value. Does it pass the 0.05 mark or not? And it's important to understand what your statistics actually say. Speaking of the actual p-value you're using, it's important to know whether you're using a one or two directional hypothesis test, because that will affect the significance value you actually use. That's a point brought up by Lay in a paper we just read. Similarly, the Detecting Job Differences paper also brought up the importance of really understanding what null hypothesis significance testing is, and kind of criticizing the traditional interpretation of it and these fixture on these just artificial p-values. And then finally, the criticism we read of the APA publication manual again drives home this point, and argues that we need to report more than just p-values. We need to report effect sizes and even confidence intervals. So again, it's just a really important point to know that the p-values are not magical. We need to understand more about what our statistics are telling us. Nonetheless, they are a common, a quick way to describe your stats, so I will go ahead and continue to talk about just simple p-values, also for lack of time. Okay, anyway, so again, there is a significant main effect if we're looking at just the 0.05 level. So if we ignore the other variable and just looked at this main effect, this factor, X1 does have a significant effect on the dependent variable Y. If we look at the second factor, X2A, we see that that actually is not a significant predictor. But if we look at the interaction between the two, we see that that is significant. And interactions, you got to be careful when you interpret them. It's not so hard when we're just using a 2x2, but if you had like a 2x3x3x2, it gets kind of tough to understand those interactions. But basically, we can just say that the effect of these variables depend on the others to produce their effect on the dependent variable. And we can show these effects very nicely in a graph of the ANOVA output. We can just look at the main effects by comparing. So if we want to look at the effect of X1, that's shown by the mean difference between these 2 points, or between the mean, this point right here, the mean of these 2 points. If we compare that dot right there to this point right here, that would be the difference between those 2 points would be the effect of X1. Similarly, if we were looking at x2a, we'd look at the mean of this line right here and compare it to mean of this line, and we see that's not very different, which was reflected again in the fact that x2a was not significant, but x1 was. And then finally, the fact that these lines cross shows that there is some sort of interaction. Just rule of thumb, I know you don't like rule of thumbs, but as a rule of thumb, if the lines are crossing or significantly not parallel, then there probably is an interaction. But it's important to go by what Rosnow and Rosenthal say, in that we should be kind of careful about interpretation of these graphs of interactions, and we actually shouldn't even use them, because it's not really plotting the effect that was tested for the interaction. Because this is a plot on the raw values, which is nice because this is the metric we use, this is the metric we as humans understand. But really, the interaction was tested on the residuals. It's based on type 3 sum of squares, so after we take out the variance for the main effect, either main effect that's in common with the interaction term, all we're left is the residuals that are exclusive to the interaction, and then we test that interaction to see if it's significant. So really, we should be plotting the residuals, not the raw values. So it's important to know that. But people traditionally show this plot here, and so that's why we have it. And that's about it. I just want to say thank you so much for a great semester. Thank you for listening to another one of these videos. I'm sure you're getting kind of bored of them by now. Hopefully you can finish soon, go have a Guinness, and enjoy your break. Thank you so much, and I will see you on campus.